This module is all about section 7.3 in your books, for those of you who have your books at home. And it's all about finding antiderivatives of problems where x's and y's are mixed together. And this is a big section for free response questions, and I'm going to have a separate set of practice free response questions that will be optional for those of you who choose to take the exam. The module is going to be devoted more to content. So remember, those AP questions that I post are going to be optional for you. So the first thing that I just want to mention is some of the language here. So when you get a direction that says, it might say solve the differential equation, or it could say find the solution to the differential equation, or find the particular solution. So what these all mean, all those directions, it means to find the antiderivative. And when we say antiderivative, the ultimate goal is to get it in the form y equals. And that'll make a little bit more sense once we dive into the examples, because usually once we find the antiderivative, so in this example here that I know I haven't started talking about yet, but this is the step where we find the antiderivative, but that's not the end of the problem. So we find the antiderivative, and then ultimately our goal is to get the y by itself. So with these problems, the part that makes them unique, or what you have to make sure you set up first, on this first step, when we get the problem in front of us, our first goal is to separate the variables. We want everything involving y on one side, everything involving x on the other side. It is safest to do y on the left side and x on the right side. If you have a problem that uses different variables other than x's and y's, look at the derivative statement. Remember, dy dx is another way to say derivative. Whichever variable is on the top, put it on the left. Whatever variable is on the bottom, put it on the right. So if we have like a dy dt, we want to have it separated like something times dy equals something times dt. But most problems here are going to involve x's and y's, but the second example I think involves x and t, so you'll see what I mean by that a little bit more on a different problem. But your first goal is to separate, so this is just pure algebra. On this problem here, I'm looking at this step. If we get the y's on the left side, so we would just multiply both sides by y. And if we get the x's on the other side, so that means that we have to move this dx over to the right side of the equation, we get something where the variables are separated. And this whole process is called integration by separation. So that's the goal. What we do once we have our variables separated is we take the integral of both sides. That's what this step says. By take the integral, that means find the antiderivative. So we separate our variables, we find the antiderivative of each side separately. On this step here, notice that when we find the antiderivative, so the antiderivative of y would be 1/2 y squared. The antiderivative of 2x is x squared. We know that we need a plus c because we need a constant somewhere, and we really only put it on the right side. We don't want to put a plus c on both sides because then we might accidentally subtract it out of the problem. Like if I had a 1/2 y squared plus c equals x squared plus c, it would be pretty easy to just subtract c on both sides and I would lose it entirely. And the reason why we can't do that is because even though there might be a constant on both sides, they're not necessarily the same constant, so they might not subtract out of the problem. So to solve that, to keep us from making that mistake, what we do is written in this step, this one, is we only put the plus c on the right side. After that, our goal is just to isolate the y, and those are the steps in here. Multiplying both sides by 2, and then taking the square root of both sides. And also notice here, so I have this line, 2x squared plus c, and notice the line above it was 1/2 y squared equals x squared plus c. So to advance that step, what I did was I multiplied both sides by 2. But you should notice that instead of having a 2c, I just have a c here. And the reason why we do that is because if c is a constant and I multiply it by 2, I just get another constant. So even though it's not wrong to have plus 2c, and if you have that on your papers, there is not going to be any deduction for that. You're not going to be penalized for something like that. But when you look at work done by other people, when you look at answer keys, you'll see that whenever we have a c, whenever we have just an arbitrary constant and we multiply or divide it by another constant, we just leave it as c. A problem that asks you to find a particular solution means that you need to figure out what the c value is. So a particular solution means we have a point. This would have to be given to you. And we're going to use it to find c. Now on this one, the variables are mixed up. I used x and t instead of x and y just to show you what that would seem like. So first, let's look at the derivative statement. It says dx dt. So we're going to put x on the left side, and we're going to put t on the right. What this also means is instead of a problem like x comma y, whatever variable's on top is the dependent variable. So when we have something dy dx, any point that we're given is x comma y. Here, dx dt is going to be t comma x. So it is going to feel a little different. And this point, when it says x of 0 equals 1, it's like a hybrid function notation type thing. So x of 0 equals 1 gives us the point 0 comma 1, which is really going to mean that when t is 0, x is 1. If you have trouble with this notation, reach out to me, but I don't want to spend too much time on it just with the example video. But looking at the example, so for this one, I do want to go over this isolation a little bit more slowly. So I'm going to give myself a little bit of space to work with. I'm going to get rid of So if I look at the original problem that was given, and the original problem that was given is all the way up here. So we have xe to the negative t dx dt equals 1. So we need to get the x's on the left side and the t's on the right side. So we are going to have, first of all, I'm going to take this e to the negative t and I'm going to just write it as a fraction. E to the negative t is the same as e to the positive t in the denominator. The x and the dx are good where they are. It's the e to the t dt that we need to move over to the right side. Since they're in the denominator on one side of the problem, they would be in the numerator of the other side. Or really, I would multiply both sides by e to the t dt. So the 1 is gone because it's really 1 times e to the t dt, which we don't have to write. So now, taking the antiderivative of both sides is the step in here. So x dx, its antiderivative is 1/2 x squared. E to the t, its antiderivative is e to the t. And we include a plus c only on the right side. Now, my personal preference is at this point, I like to find the c value here. For me, it's a little easier algebraically to find it now, But if you would prefer, you can isolate one variable and then find C. You get the same answer either way. I prefer to do it here, and I find the algebra a little bit easier when I do it that way. So that's the steps that are taken in here. So using that point, 0, 1, so when t is 0, x is 1, if we plug that in and we remember that e to the 0 is equal to 1, we can find our c value. We get c is -1/2. So when we plug that in to our equation, so now we have, instead of what's up here, 1/2 x squared equals e to the t plus c, now we know it's 1/2 x squared equals e to the c minus 1/2, because we know what the c value is, so we can plug it in. Once we have the c value, now our goal is to isolate the dependent variable here, that's x, and those are the steps that are taken in here. This is isolating the x. And the way that we have it set up, the variable that we want to isolate is always the left variable. Because the left variable should always be our dependent variable, and that's the one that we want to find. So for a lot of the problems in this section, I think that the hardest part for some of you is going to be the algebra involved. So please don't hesitate to reach out. What I'm going to do next is just go through some examples with you. I did post my PDF of my examples, so if you prefer to just look at the answers instead of watching the video, then that is your choice.